what the hell.
कसलं आहे ते?
Okay, maybe चालू झालं. Yeah, yeah. चालू झालं. Okay, let's go with the problem now.
Shall we start?
Yeah.
Okay. So, what we can see through this problem is we have given uh, rotated matrix, rotated linked list actually, and we have to generate the particular matrix. The matrix rows and columns are given. And the head means the whole spiral matrix in the form of linked list is given. We need to convert this linked list, rotated spiral linked list into the matrix. One of the intuition is for starting with the 3 by 5 matrix, generate 3 by 5 matrix and fill it with -1. And later, what we can do, we will traverse this linked list. And how we will traverse? From 0 to 4, from 0 to n minus 1, we will traverse. And till when we will traverse, till head is not equal to null. That we have while loop, and when we reach that I pointer to the n minus 1, okay, we need to change the direction of traversing. So here, what we are doing, here we are incrementing columns. Okay, when we reach here, we need to increment rows. When we reach here, we need to decrement the columns. When we reach here, we need to increment rows till when our previous one. So we need to maintain around 4 pointers, I guess, row name, row number, and column number. So how we will start? So first we need to create a vector. um,
I think the matrix logic is same, just like we have to pass through a linked list, right?
Yes, we have given linked list of spiral, and we need to convert it into regular matrix.
Okay.
We have given linked list, and we need to convert it into the matrix.
Yeah.
So first we will have solution matrix, and I guess here code was, what was the code? 1 minute. Huh. So first column, row name, row number, then vector in column number and -1. So here we have initialized our solution vector to by 2 matrix, and now we need to traverse the linked list. Okay. So till when we will traverse, while head not equal to null. Is there null or null PTR?
Null PTR. Or you can use null as capitalized keyword.
Okay. Okay. So we are traversing. So what we need to maintain is uh, the ending row number. Means we are starting from 0 to n minus 1 for this loop. But for inner loop, we will traverse from this way. So we need to decrement each time the ending row. So how we can do? We have four for loops.
Yeah,
For
but in constant, are we given that the length of the linked list will be m by n?
no, It's not given. So that's what the catch is. Here, if you see, here whole linked list is not given. 2 points are remain
Okay,
unfinished.
so uh,
That's why we have
like
initialized with -1 only.
okay, okay. So like okay, I got it. I got it.
So there are four for
I
loops.
think we should not do while head isn't equal to null ptr. But
Mm,
well, let's go with your approach. I think we can figure it out on the way.
okay. So uh, column column is column number. First we have column in C is equal to 0. We have this column top. Okay. Column bottom is n minus 1. We have n minus 1. Sorry. We have row left is equal no, actually, column left column right row top is equal to 0 from row bottom is equal to
M minus one, right?
1. Okay,
Yeah.
so we have these four. So first we will traverse column from column left to uh, column right.
Okay. And our column will increase, right?
So we are traversing from here to here.
Yeah.
So our row number will be constant. So solution of uh, top row. So top will be constant, and we will be changing column is equal
Yeah.
to head comma val. Okay. So when we have cleared this row, we will increment the row number. So it will be column row top plus plus. Like we same, we need to traverse from this to this. So we will traverse a row top to bottom. So we from row top is to R is equal to row bottom. So here our column name will be same. But in the column right will be same. Okay. So we have traversed this also. So we need to minus
Increment.
column right. Please check. So we will traverse see um, column right.
Column right till column left.
Mm, ah,
We'll column minus minus, right?
V minus 1. Yes. So here also solution the row bottom.
Thing, and we will now increment the row bottom.
Hmm. Decrement actually. We need to go upwards, right?
Yeah, yeah, yeah.
Hmm.
Decrement.
So from column bottom, row bottom. So I hope
Yeah, one thing that you didn't like pass through the entire, you didn't traverse in the linked list, right?
means okay. Head.
We have to update the head. One more thing, I
Okay,
think,
for each
yeah,
one,
that's
right?
why I said we shouldn't use while head is not null pointer, right? So one thing we can do is, okay, so we can like let it rest and
What? Hello. What?
yeah, we can let it rest
Hmm.
as it is. We can have, okay, so how
Yes.
we will do it? Yeah, head is heads next, right? That will be the same. No problem in that. Okay, one thing is we have to
Yes.
get, no. We have to get current value. What if our rest of the linked list is null, right?
Means.
Like if we have entered our linked list, then we have to add minus one.
But we have already initialized minus one.
Okay, then it's okay. Okay. Then it's okay.
But what?
What is saying heads value?
Yes. Okay. So one more error which we have occurred here, that we this loop traverse whole this columns, but our linked list ends here. We cannot traverse these two.
Okay, so we can put the check in the every for loop.
For
Yeah. No, not there, not there. In column right, right? Is C is less than or equal to column right,
here
and we can put and like yeah. Just copy it from the while loop.
this.
Yeah.
I guess there might be any optimal solution we can find.
I don't have any idea about that. We can write cleaner code, but I don't think so. We can optimize it.
Let's see. It will be, I guess, n square or n.
En into M. Yeah, anytime. I think just go to the editorial. We could get a better approach. Yeah, there is a simulation. I think there is only simulation approach. Maybe you have to see. Is there? No, no, no. This is our same approach. The same approach that we have used.
but
Okay,
okay,
so what they did?
they have done something different, I guess. Movement. They have solved in n complexity. New. new- is something different level only. Hello.
Hmm.
Have you got this approach? Because I did not got much.
I think it is similar to somewhat DFS, right?
Okay.
It is go into that approach. Like try to compare it with DFS. I think we could be able to grasp it easily in that way.
Okay.
Did they give complexity analysis? I think it is same. It is M by N. Can you check?
Yes.
Can you check the complexity analysis?
M
Yeah,
into
it is.
N,
Yeah,
I
yeah,
guess.
it is M into N.
It's
Yes.
same.
Yeah, yeah, yeah. Cause it is like recurring call, right?
Yes. Okay, but it's okay. Here we are doing this.
We are like moving into the spiral.
Okay. If the complexity remaining same, our approach might be easy.
Yeah,
It will
it is
be
easy to
healthy.
understand. I think we should ask ChatGPT to like write it in the cleaner way.
Mm.
No, 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 no. Optimize. Write it in the cleaner way. Yeah, yeah, they have like just commented a little bit and changed the variable name. They haven't done anything
Mm.
drastically
It's just.
different. Yeah,
Mhm.
yeah.
So should we ask that is there any more optimized way or
I
not?
think it should be available in our editorial itself.
Okay, okay, okay.
Just check it there.
No, there is only one solution given, I guess.
Then there is no optimized solution, I think.
Okay, okay.
Yeah, you can ask ChatGPT if there is a possible way, then it is good to know. Okay.
Okay. So should we solve some some other questions? Or what's your plan? Hello.
Yeah, 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 I'm listening.
So I'm asking, should we solve some other questions
Yeah, I think we can go with
or SD sheet?
uh,
Should
yeah, now before like just solve yeah, 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 this roadmap. I think we should go to I think we have solved the valid Sudoku or didn't or we did not. I think we haven't solved the last question, the last question. Longest consecutive sequence, yeah.
okay. Given an answer to the written and time. Oh,
Okay, one approach. No, no, there is no one approach. It is we have to do it in of one time, right? What is union find operation? I think it is done on the graph, right?
hmm.
Okay,
Union
so
find means
leave it, leave it.
we
We
will check.
can do it. In,
So what
yeah,
we need to do?
oh, hello.
Yes, yes, yes.
Yeah, we. I think we can put the entire array into a heap
Okay.
like min heap, and we can just keep popping the element from the front
Hmm. Yes. Hello.
Hmm.
Hmm. And we will count it, right?
Yeah, yeah. Then we can have the logic that if it is consecutive, or we can have max consecutive, current consecutive, that whole thing. I think we should use priority queue. Sorry, yeah, priority queue, which will be holding minimum value at the top of
Okay.
at the front of it.
Okay. Priority queue. So there is also mention of hash table. I thought that here it's nine. So 1, 2, 3, 4, 5, 6, 7, 8, 10. Oh, so if there is a repetition, we should not count that, right? Or
Did
what?
they count it or did they not?
Mm, there are 10 elements total.
Okay, so they have given 9.
Ah,
Okay, 0 to 8, 0 to 8, right?
yes.
Yeah, yeah.
Means they have counted only once, but they have also asked for consecutive. Means
Yeah,
the
yeah,
minimum
yeah.
difference should be one. What it
Yeah, yeah.
says? Consecutive elements means.
Yeah, yeah. Consecutive means, let's say,
Means common difference should be same.
no, 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 no. Let's say there is a number array with elements 1, 2, 3, then 8 and 9, 10, 11, 12. So 1, 2, 3 are a consecutive sequence. Is a consecutive sequence. After that, 8, 9, 10, 11, 12 is another consecutive sequence. So there are two consecutive sequences.
Okay. So
Yeah,
we need to find that. Uh,
maximum.
okay. But how we will get that? What is the consecutive sequence?
Yeah, if you have in the main heap, it automatically grows into, like, it automatically comes in the sorted array, right?
Yes, yes. Hebrew software.
But I think inserting into the priority queue is log n operation. We have to check that. If it is a log n, then our time complexity goes into n log n. Priority queue, C++.
We are checking for pushing, right?
Yeah,
Okay. We will create a min heap with priority queue using greater. Int.
pushback. Okay, so they haven't give. Just go to the, I think, c++.com. There is yeah,
Yes.
c++.com. Yeah, yeah, yeah. They give everything. They give everything. Yeah, push. So go into the push. Yeah, I think it is an login. It is a login then.
Okay.
Maybe. Yeah, up to logarithmic. Yeah, it is a log.
Hmm. Okay. So we will use min heap, right? Okay. Priority queue.
Then we don't need to use the priority queue. We can just sort it. But our time complexity goes beyond often, nah?
But if we sort it directly, it will be n log n, right?
Yeah, yeah. So we have to insert each element. We are going to insert n elements.
Okay, so
and into
if we
login. So
was
it comes to that rabbit hole.
which has constant complexity of inserting
Hash map. Set also has a login for popping and pushing.
unordered, unordered, both
Yeah,
unordered.
yeah. How can we do it in the map?
So one way will be set and map, right? If we have inserted in a set, we will get all the constant. Means,
Yeah, but inserting an array gives us time complexity of and login. It is not
inserting
constant.
into unsorted set, unsorted set gives means constant complexity, right? Inserting.
Yeah. Check. I was unaware about unsorted set. Yeah, time complexity. This is randomized. Okay, so it is OFN. Worst case is OFN.
Hmm.
I don't think so. We will go to the OFN because we will not be like utilizing whole of the given stack and heap.
Okay.
Like memory, we won't
I
exceed that
said
memory.
we will get whole means we will insert into the set, but it's unordered, so it should be random.
Yeah,
So,
but can we index? We have indexing on the given unordered set.
okay. So, what is the time complexity of finding the element in unsorted map?
I think it is log n. Set means log n because set I think uses bit in the implementation itself.
Yes.
Log n because it is I think it use some type of binary search tree.
No, map operation. Unordered map.
Yeah, unordered map is often
Uh, a regular map.
okay. You talking about unordered map. I thought you were talking about unordered set.
No. So, if we have one map where we
Hmm.
counted all the elements, so we have got unique elements, right? So, what we can do?
Look, we will be able to get like all the sorted arrays. One thing we can do is like insert all of the elements present in the array into the set. Sorry, unordered map.
Okay, and
And after that, we can go from shortest element to the largest element of the array itself. Right?
uh, but
For
it's unordered, right?
yeah. Shortest element from the array, right?
Okay, okay,
And in that, we will check if current element is present in the map. And in that for loop, we can have the logic for finding the longest subsequence, which will have the consecutive elements. I think this algorithm will we will be able to figure out in of n time. And n means the difference between shortest and largest element, not the size of array.
okay. So, should we watch neat code, or what should we do?
Uh, I think I can solve it. I mean, I'm not 100% sure, but I think I got the intuition on how to do it. I think first of all, we will go with my approach and then we'll
Okay, sure.
figure out
Yes,
if
yes,
we
sure.
can't. Yeah. So I will share my window.
Okay.
Are you able to see it?
Yes, I will load
Yeah.
mine.
What was the problem number?
128.
I think I have solved it, but I have used the inbuilt sort method.
Okay, you already solved.
Yeah, but it was like it. No, I didn't submit it, but there is it shows no submission. I think it would have gotten TLE error.
Okay.
No, no. I don't know, man. What is the
Okay, I
problem? But
guess
we will just scrap it.
and because of error or time remaining, skip that.
Yeah. Okay. So we will start with the unordered map first. I think each element should be distinct, or no, there is no such thing. Okay, so for in nums go map of num plus plus, to that we will have a for loop. Okay, so we got right answer here, but we are getting wrong answer here. So we are getting output as -1. Why is that the case? Searching from minimum element. What minimum element of AE? Hello?
Yes, yes, yes.
Yeah, yeah, yeah. So it is working
Minus.
for this. I don't
Hmm.
think, I don't know why it isn't working.
Current sequence. Okay, minimum, maximum. Mm, okay.
We got output as one. So let's go with. I think we are not updating max sequence length value. Yeah, yeah, yeah. Why is that? Why is that?
Max sequence length.
Okay, so I don't think so. We need to do. Yeah, 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 yeah. Yeah. So
Oh,
like in previous thing, what we were doing, if whenever this condition is false, we were updating the max sequence length. So we got output as -1. So okay, so default value
okay.
should be 0. Okay, default value should be 0. Okay. Yeah. So what was I saying? What was I saying? Okay, so we got wrong answer again. Expected 1. We got 0. Answer 0.
Okay,
Okay.
from min e I less greater than equal to. Yes.
Yeah, but if we say equal to, then okay. Let's check. Let's check.
Because min e max e will be also
Yeah, yeah,
there
yeah, yeah,
in.
yeah, yeah. What I was saying that since we are checking it here,
Okay,
right? We are going I plus one, so we will get like out of bound, right?
we need to check that also that should
Yeah, yeah,
not
yeah,
be.
yeah. No, 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 no need for that. Cause if even if it is out of bound, the
Okay, dot find method
yeah, yeah,
will
dot
return
fund
in.
will give like yeah. Okay, so we are getting TLE here.
Okay, it will be 99999.
Yeah, yeah,
Okay,
yeah,
that will
yeah.
cause issue.
I was thinking about the edge case where like there will be two elements, one will be 0 and one will be 1000. Right.
Okay,
Yeah, it was back in my head, but I didn't think of it that much. That would be a bottleneck. But yeah, LeetCode has good test cases. Yeah, so they are going with linear strategy. Okay, simple. Okay, let's check this for X. Okay, I think we should check out neat code solution, right?
okay.
Do you think I have added added some value with this solution, or it was just a waste of time?
No, that was good because if you have compared to the company will not have that much test cases as of lead code. This solution will work because we have seen
Let's solve
Accenture
leak.
as only one test case as hidden. That was
Yeah,
also basic.
yeah, but we aren't targeting like
Ah, okay. Yeah.
yeah, yeah, you got my point.
Okay, that
Code
question was
120.
from Google.
Yeah, yeah. So it was hard like 4 years
Okay.
ago. It
Back
was in the
then,
hard karate. Yeah, I think yeah, but they
A
moved it into
longest
the middle.
consecutive sequence.
means
This is a pretty
they are
interesting
also
problem, and it's actually
improving the quality.
Yeah, yeah. Edit code is constantly like changing the parameters as per the community. If community says it's too hard, they will. I think there was an instance where they moved easy to hard by just adding two extra edge cases.
Okay, okay. Or
Yeah,
maybe based on the submissions, if the too much submissions, correct submissions, they might have lowered the what we can say level.
yeah, that could
Maybe
have been.
backend some algorithm will be there.
Yeah, yeah. No, they do it manually. It is not automated.
Okay, okay, okay.
So they do it manually. Everything is marked manually.
been asked by a lot of companies, including Google, for a coding interview, so I think it's a good problem to understand. So we're given an input array of numbers, right? In this case, we have 6 numbers, and we want to find the longest consecutive sequence. In this case, the longest consecutive sequence is 1, 2, 3, 4, right? It doesn't matter what order the numbers appear in the input array, we just want to know the longest consecutive sequence that we can make from the input array. Now, the most obvious way to solve this problem is just by sorting, right? So if you look at the sorted array over here, we have obviously one consecutive sequence of length 4, right? 1, 2, 3, 4. They're all consecutive numbers. We also have another one that's length 1, just 100. And we have the last one that's also length 1, just 200, right? Now, this is definitely a valid solution. We can definitely code this up, but the time complexity is going to be O n log n. So the question is, can we do better? So this is LeetCode hard. Obviously, the solution wouldn't be this simple, so we can do better. But how do we get there? Now, the first thing to do is try to visualize the problem in a way that it makes the problem really easy to understand. So I visualize the problem by drawing out an imaginary number line, right? So we can kind of see what the sequences actually look like. This makes it a lot easier to recognize the patterns. So we know we have one sequence that starts at 1, 2, 3, and 4. We have another sequence that comes after it, which is one number, 100. We have the last sequence with also only one number, 200. So just by looking at it, we can tell we have 3 distinct sequences, right? That's something to recognize. Now, by visualizing it, we can kind of try to approach how would a human solve it? Well, the easiest way is just look at each of how long they are. So let's look at the first sequence, right? We have 1, 2, 3, and 4. So this sequence has 4 numbers in it. We have the second sequence, just 100, so it only has one number in it. So it's a sequence of length 1. The last one is also a sequence of length 1. Now, this is so easy to solve when you visualize it and try to approach it how a human would. But can we actually convert this into code somehow? The answer is yes. So the most important thing to notice is that we have 3 sequences, but how can we identify what makes a sequence? How can we actually start at the beginning of a sequence? The thing to notice, and this is really easy when you actually look at the picture, that each sequence has a start value. The start value, in this case, the start value for the first range, or the first sequence, has no left neighbor. The first value 1 has no left neighbor, right? That's really obvious. Look at the second range, 100. It doesn't have a left neighbor. The third range, 200, doesn't have a left neighbor. So we can get the start of each sequence by just looking at our entire array of numbers, right? And figuring out which numbers don't have a left neighbor. So meaning if we wanted to check if 1 had a left neighbor, we would check, does our array contain the number 0? If we wanted to know if 100 had a left neighbor, we check, does the array contain 99? The easiest way to do this and the most efficient way to do it is by taking our initial array and converting it into a set. So now to find the start ranges, let's start iterating through our array. So we get to the first element, 100. Does it have a left neighbor? Well, we can check our set. It doesn't have 99 in it. So this is the first, so this is the start of a sequence. So let's get the length of the sequence. We start at 100. Now to get the length of the sequence, we want to count how many consecutive numbers come after 100. So we want to know, does 101 exist in our sequence? Looking at the number line, obviously it doesn't, but how can we check this efficiently with code? Well, we already have a set that takes up this entire array. So let's just use our set to check if 101 exists. Since it doesn't, we can no longer continue this sequence. So now we get to the next number, 4. Is 4 the start of a sequence? Let's look at our picture we drew. 4 is not the start of a sequence. And we can check this using our set. We would check that it does have a left neighbor, right? 3. So it's not the start of a sequence. We're not going to make a range from it. We get to the next number, 200. Is this the start of a sequence? Looking at our picture, yes it is. And we know that 199 does not exist in our set. So let's make the sequence. Let's try to make it as long as we can. We check, does 201 exist? No, it doesn't. We can tell that from our picture, and we would use the set to determine that. So now this is as long as we can make this set. So let's get to the next number, 1. Is 1 the start of a sequence? At our picture, we can tell 1 does not have a left neighbor, so it is the start of a sequence. Now let's check if 2 exists in our set. It does, so we can make this sequence a little bit longer. Now let's check if the next number, 3, exists in our set. Yes, it does, so let's make it even longer. Now does 4 exist in our set? Yes, it does. Now let's check if 5 exists in our set. It doesn't, right? There is no 5, so we can't make the sequence any longer. So now let's continue through the array. 3. Is 3 the start of a sequence? No, it's not. It has a left neighbor 2. Now let's try 2. Is 2 the start of a sequence? It's not, because it has a left neighbor 1. So we went through the entire array. We created all the sequences we could. The first sequence is length 1. The second sequence is also length 1. The third sequence is length 4. So this is the longest sequence. Now we took a really complicated problem, or seemingly complicated, and we broke it down so easily. All we had to do was iterate through the initial array, use a set, and check if values had left neighbors, and if they didn't, then they were the start of sequences. We made this problem so easy with only using one data structure. Since we only had to iterate through the entire array, and we had to expand each range, we know that we're only going to visit each number at most twice, so our solution is very efficient. And we did have to use additional memory to create a set because we wanted to check if neighbors existed. So for the memory complexity, it is also big O of n. In this case, n is the size of the input array. So now let's get to the code. So we remember we need to create a set from the initial array nums. So it's really easy to do that in Python. We can just pass the array into a set constructor. Next, we want to keep track of what the longest consecutive sequence is. Initially, we can say it's 0. So we want to iterate through every number in the nums array. And we want to check if it's the start of a sequence. And we can check that simply by checking if n minus 1 does not exist in our num set. If this number doesn't have a left neighbor, that means it's the start of a sequence. So now we want to get the length of the sequence. Initially, we can say the length is 0. And we want to keep getting each consecutive number and checking if it exists in our num set. If it does, then we can keep expanding the length. So initially, I'm going to check n plus length because that's going to check the current number. Initially, length is 0, so we're just checking the current number. As it As the length grows, we'll check more consecutive numbers. At the end, we could have potentially found the longest sequence, so we want to potentially update our longest by just taking the max of the current length we just computed, as well as what the longest originally was. And it's really that simple. So now all we have left to do is just return what the longest the longest sequence was that we just computed. So we did this in such a small amount of code. Now let's just run it to see that it works. And it works perfectly. So this is a linear time solution and a linear memory complexity solution. Once we visualized the problem, the solution became so easy to derive.
When I was 15 years
Let's solve LeetCode 128 longest consecutive.
Okay, longest.
Okay, so our bhaiya also have.
So what we can do is we can loop through this array, check if that's the initial element or not. We can check if 100 minus 1, which is 99, exists or not. No, then that means 100 is the initial element. We don't have 99, that means we got 100. Now we need to find if there is 100 plus 1, which is 101. Exists? No. So in this case, what is the
Suppose you have an array of integers and you want to find out the longest consecutive sequence inside this array. Now the longest consecutive sequence here is this array of 4 where we have 1, 2, 3, 4 consecutively. Now the fastest way we can do this is to check if we can make a streak from that number. So 101 is not in this list, so we move on to the next element until we're at 1 where we can actually build a streak, and the streak is in this array. We can keep incrementing until we don't see the streak because we don't have 5. Now this operation to build a streak and to look up the number is going to take off an operation, and we're going to do this for every single element in this array, which is going to bring our time complexity to O of n squared. Now we can optimize things where instead of looking up every single element and building the streak, what we care about is actually the start of the streak to build the longest streak, and we can utilize a set to store these elements and ask if element n-1 is in the set with a constant lookup. We can determine if they are the start of the streak.
Okay.
Let's solve LeetCode 128. And we want to keep getting each consecutive number and checking if it exists in our num set. If it does, then we can keep expanding code. Now let's just run it to see that it works.
Hello.
Yes.
Yeah, this approach is only, I think, viable with Python. How can we do it? I think we are unaware about data structures that we can use, right? I don't think so anything else is a problem.
Find well.
Okay.
Okay, n-1 in num set, not in num set. Okay, is not in num set means dot find, right?
Yeah.
Because we have set is first if loop will be dot find. Second while loop will be also dot find.
Yeah.
So both side we will check if this.
So I don't know how they do it. They haven't given. What is the problem of 128? Okay.
Check for neat code IO.
128, 128. Not. Yeah, get screenshot. 128.
Okay, directly control F and search.
No. I think there is a. No, not frequency. I think screenshot. Yeah, we have to go to this. Screen 100. We have to go to 128.
Okay, not knowing that. This is good.
Yeah. So brute force. Oh, they solved in Ncube also. Wow.
and they are giving a TLA for us.
No, no, no. I think it. They. I think I don't know, so it's considered. No, it won't get accepted. Okay, so sorting, intelligent sequence building.
Something different. Okay, set. Have set. Ah, yes, same.
Yeah, yeah. The approach was same.
Uh,
I think we can just use.
we can parse that screenshot. Only crop that. Only.
Yeah, yeah, yeah. I have just cropped this. You can see it here. I think.
Mm.
I think you are not
Okay,
able to see.
don't worry. We will get in C++.
Yeah, you can see.
No, yes, definitely.
Okay, so it for okay. Longest consecutive. Okay, I think it is used. So what it did. Okay, so another set. Yeah, from the begin. Okay, so after that for n, if n minus one. Okay, so file nums dot set. I think yeah, yeah. I got it.
So they are checking for -1 as easy snippet said. First we will check for -1. If -1 is present, then okay. If -1 is not present, then only we will enter into the condition, right?
Yeah, yeah.
And then we will check for its next one, consecutive means till how much we will get, n plus length means from 0, 1, 2, 3, will so on until the loop end.
Okay. So check if it's start of the sequence. We will check if it is it start of the sequence? Yes, it is the start of the sequence. Then we will assign the length to the 0. After that, we will increase the length up till we will get n plus length in our element. Okay, so time complexity will be actually n into k, where k will be the length of our, you know,
K will be length of consecutive list, right?
yeah, yeah, yeah. So it is not like completely that.
Means every time there will be not the every time.
Yeah, 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 yeah. It not will be every time, but let's say there is like 1,000 elements, and every element is having like five consecutive elements, and after that, last one is having six consecutive elements. So yeah, that is the worst case. So we are giving the time complexity for the worst case itself. So in that worst case, I think the time complexity will be n into k. But I don't think so we should go into that much depth. Okay, so we will start from for in so num in nums. Okay, so we will check if what we will check. So in num set. Okay, they have used num set. Okay, num set dot find. What we will find, current number minus 1 is present or not. If it is not present, then what we will do, we will have length started with 0, then while what we will do, while num set dot, we are going to find out the num plus length elements. What we will do is length plus. So sorry for the disturbance, but yeah, so we will increment after that we will have, okay, so longest is there, we will have longest is equal to max of longest and length. I think it should get accepted. Yeah, okay, so I will give you both of the approaches. Heman. Oh shit,
Yes, yes.
I wasn't recording the screen. I was focusing on something else. Shit. We were getting black screen. After the YouTube video, we were getting black screen. But hey everyone, whoever is saying this, this is the optimal approach which ChatGPT gave us.
Okay, it was pretty much same, right?
Yeah, yeah, yeah. It was same as the NEET codes video.
Oh, check what other solution is in that bar graph.
Yeah, they have you also used SEP.
Okay. Okay. Then it's okay.
I think we should copy this and we can just paste it.
Yeah, there is a issue. Okay.
No,
Okay.
there is
So
no issue. I don't know. I don't know what.
iterator also.
Okay,
Yeah.
so they are
We're
parsing
giving
through the
auto.
set itself. They are parsing through the set itself.
So what was our solution then?
I think we were parsing in the array.
No, we are passing set. We what we have done, we have used dot begin dot end. Maybe because of that, but they have implemented loop at their end.
I don't think so it makes that much difference.
Okay.
But we will check. We will check. I think iterating over. We are iterating over the vector, right? And they are iterating over the set. I think that makes the difference. Okay, so there is an error. Nums. Okay. Yeah.
What difference they have made? Okay, while dot find, I guess. While dot find in
Oh
second
no
while
no
loop.
no no no. See here, see here.
Okay.
They are iterating over the set. We are iterating over the vector. That makes the difference.
Okay. Fine.
That's
Okay.
what I'm saying.
Okay. I didn't notice.
Yeah. I think vector has linked list and set has, I think, somewhat binary index tree type structure,
Okay.
right? So
And also set eliminates my duplicates.
yeah. It eliminates duplicates. Yeah.
Maybe it's traversing time. Maybe it will be optimal.
Yeah,
Instead of
they use BIT, na. So
ah,
BIT has like fastest traversal. I think it has the fastest traversal. BIT has the fastest traversal. Okay, so here we are passing over the vector, and here they are passing over the set. That's why we are getting the optimization in the set. Okay, got it. I will give you. Okay, that should be the end of stream, I think.
yes.